Today we are going to discuss some problems related to equilibrium and Lami's theorem. So in this problem, a weight of 2 kilonewton is supported by two strings as shown in figure. So find the tensions in the strings. So if you observe in the figure, a weight of 2 kilonewton is attached to the two strings. This is string 1 and this string 2, and this is a support. So using this support, these two strings are trying to pull the weight in upward direction, because always this weight tries to move in downward direction due to gravitational force. So weight is attached to the two strings. So these strings, what are they going to do? They are trying to pull the weight in upward direction. So in that situation, these strings will be under tension, or we can call it as so these strings will stretch out to pull the weight in upward direction. So that stretching is here we are calling technically tension. So the tension condition arises in both these strings. So due to that tension, some forces are developed in these two strings. Those forces we can draw using free body diagram. So first we should know what is free body diagram means. So if you remove all the supporting elements, by removing all the supporting elements, if you draw any diagram, so that diagram is called free body diagram. So free body diagram simplifies the problem, and it also helps in the planning of logical steps to solve the problems. So it also establishes the magnitude and direction of known forces, and helps in assuming the direction of the unknown forces. So free body diagram means first you should remove the supporting elements. So whatever the supporting elements are there, first you remove those supporting elements. So here we are not going to draw the supporting elements. We are going to show only forces in their directions. So here weight W of weight, some weight 2 kilonewton. This weight of 2 kilonewton, always it is acting in downward direction. So two strings are attached. So these strings they are going to be under tension. So due to the tension, some forces are developed in these two strings. So those forces acting in upward direction, because these forces tries to move this weight in upward direction, because weight is always try to move in downward direction, and these strings tries to move this weight in upward direction. So whatever the force developed in these strings are called tensile force. So the tensile force here we are assuming T1 tensile force. So due to the tension condition, here tensile forces are going to be developed in these two strings. So those tensile forces here we are assuming T1 the first string, and here we are assuming tensile force T2 the second string. So we have to find out these tensile forces whatever the developed in these two strings. So these are the unknowns. So we know known force 2 kilonewton, and we have to find out these unknown force. So this is called a free body diagram. So in this free body diagram, we are not free body diagram. So in this free body diagram, we are not going to draw any supporting elements. So there are no supporting elements are there only. So the free body diagram shows only the forces and their magnitude and directions. So to find out these unknown forces, so here in the problem some data has been given. So here string 1 is making an angle 45 degrees with the support, and string 2 is making an angle 60 degrees. So if you observe here, if this is 60 degrees, So here we are drawing line, horizontal line. So if this is 60 degrees, so this angle also becomes 60 degrees because alternate angles are same. So if it is 45 degrees, so the remaining angle, so the alternate angle will also become 45 degrees. So this is 60, this is 45, and this angle, so 60, 45, this is a triangle. So 60, 45, 105 degrees is already completed. So the remaining angle is 75 degrees. So this angle is 75 degrees. So here we are going to draw. So the angle between T1 and T2 is here. It is 75 degrees. So this angle is 60 degrees. So horizontal to this T2 is 60 degrees. The angle between T1 and horizontal is 45 degrees because alternate angles are same, 60, 60, 45, 45. So that's why here we have written like this. So 60, 45, 105. So total this is 180 degrees. So in that also you can calculate this is 75 degrees. So this 60 degrees means here the angle is 90 degrees. Here the angle, the horizontal to 2 kilonewton is 90 degrees. So now here we are going to run again. The angle is here T2, T1, the 2 kilonewton. Angle between T1 and T2 is 75 degrees. And angle between T2 and 2 kilonewton is 60 plus 90. So total 150 degrees. 150 degrees. And angle between T1 and 2 kilonewton is 45 plus 90. Total 135 degrees. So now we have three forces. So these three forces are in equilibrium. So we are going to apply Lami's theorem. So using Lami's theorem, so according to Lami's theorem, the force is proportional to the sine of angle between the other two forces. For example, if you consider T1 force, T1 by sine of angle between other two forces. Angle between other two forces T2 and 2 kilonewton. Angle between them is 150 degrees. So T1 by sine 150 degrees equal to next force is T2 by sine of angle between other two forces. Other two forces T1 and 2 kilonewton. The angle between them is 135 degrees. So T2 by sine 135. Remaining force is 2 kilonewton, 2 by sine 75. The angle between other two forces T1 and T2 is angle between T1 and T2 is 75. So 2 by sine 75 degrees. So now we have this equation. From this you can easily calculate T1 and T2. So T1 equal to 2 into sine 150 by sine 75. So you will get some answer. T2 equal to 2 into sine 135 degrees by sine 75. So using calculator, so if you calculate, you may get 1.035 some kilonewton. and T2 1.46 kilonewton. So if you calculate, so whatever the answer you get, so write that answer. So this is the problem using Lami's theorem. So if you have any three forces in equilibrium like this, then by applying Lami's theorem you can easily find out unknown forces. So the second problem, another problem is here, a lamp weighing 5 Newton is suspended from the ceiling by means of a wire. It is pulled to one side by horizontal cord until the wire makes an angle of 60 degrees with the ceiling. So find tension in the wire and cord. So a lamp weighing 5 Newton is suspended from the ceiling. So here we can do like this. This is the ceiling and a lamp of weight 5 Newton is suspended from the ceiling by means of a wire. So using a wire, a lamp of some 5 Newton. So weight here is 5 Newton. So it is suspended by means of a wire. After that, what is he doing means it is pulled to one side by horizontal cord. So cord means it is nothing but another wire only. So it is pulled to one side by horizontal cord until the wire makes an angle of 60 degrees with the ceiling. So using a horizontal cord, we are pulling this wire using a horizontal cord, we are pulling this wire until it makes an angle of 60 degrees with ceiling. So whenever you try to pull this wire with this cord, you are pulling means here some force you are applying, so that force it is developed in the cord. So you are applying some pulling force. So here pulling force is tensile force only. Tensile force using whichever going to be developed in this cord. So here you are pulling this wire with this cord until it makes an angle of 60 degrees with the ceiling. So if you pull, so whenever it will make an angle of 60 degrees, then you are going to stop pulling. So here whenever it makes an angle of 60 degrees, so at that time that wire will be look like this. It is showing this figure, second figure. So here it is 5 Newton. So with this cord, so this is cord and the force developed in this cord is, here we are assuming P. So it is pulling force. Pulling force is nothing but tensile force only. So this pulling force is nothing but tensile force or tension in the cord. Tensile force in cord. So this is the pulling force developed in the cord. So here whenever this wire makes an angle of 60 degrees, then the figure that condition will be look like this. So now we are going to the free body diagram. So here free body diagram means you have to remove this support. So by removing that support, so it will be look like this. So because of this pulling, tensile force will be developed in the cord also. So this is the tensile force or tension in the wire. here we are assuming that is T. So tension or a tensile force in wire, this is pulling force P, and here it is W 5 Newton. So here in the problem, from this image, from this figure, we can understand that if this angle is 60 degrees, then this angle will also become 60 degrees, and here it is 90 degrees. So the angle between this tension in the wire and 5 Newton is total 60 plus 90, 150. So the angle between T means tension in the wire and the 5 Newton is total 150 degrees. So now we got one angle, that is 150 degrees, and the angle between 5 Newton and P is a horizontal force, because horizontal chord here we mentioned. So here P and 5 Newton, the angle between them is 90 degrees. So 150 plus 90, so 240. So the total angle is 360 degrees. The remaining angle will become 120 degrees. So now we can apply Lami's theorem. From Lami's theorem, so P by sin 150, sin half angle between the other two forces. Sin 150 degrees equal to T by sin 90. Sin half angle between the other two forces equal to 5 by 5 Newton by sin 120. So from this equation we can calculate unknown forces. P equal to 5 sin 150 by sin 120. So you will get some 2.8 Newton, and the tension in the wire so here we are writing, so T equal to 5 sin 90 by sin 120. We are going to get some 5.7 Newton. So these are the unknown forces. So P is the tensile force developed in the cord, this is some 2.8 Newton. So T is the tension in the wire is 5.7 Newton. So if you understand the problem, then first draw the figure. From that figure you can easily calculate the unknown forces if you know the angle between all these three forces.